continuing on this idea of if we know what the shape looks like, it can help us solve problems if we know what the picture is. So we've talked about the basic curves. Now let's talk about shifting the basic curves. If I add a constant to a function, this has an effect of shifting. Another way of thinking about this is grouping a number with the y. So when it's plus a constant, I can't group it with the x because the x is inside the function. So the plus a constant, if I moved it to the other side, I could group it with the y. So that's another way of thinking about it. And that explains why it creates a vertical shift, because it's actually the y value that's being affected. And we'll move up or down c units depending on whether c is positive or negative. When we group it with the x, so now it's function x plus c, so it's the x value that's affected. So the curve will be shifted horizontally, plus or minus. Now, how do you know where it gets shifted to? Have a look at the grouping, and whatever would make that grouping equal to 0, that's where you've shifted the curve to. Negative function x. So you get the whole function, but you make it negative. So this has the effect of reflecting it in the x-axis or flipping it upside down. Because what was positive in the y values will now be negative, and what was negative will now be positive. So we flip the basic curve. Whereas if it's function negative x, then it would be in the y-axis. So we'd have a horizontal flip. So again, what was negative becomes positive, what was positive becomes negative, but now we're talking about the x values. That's what's been affected. So let's have a look at the basic idea. How would I draw this curve? Obviously, it originally came from a quadratic, and we completed the square and we've come up with this idea. But by looking at this, we can see the shift. So the basic function is x squared. So I know it's a parabola I'm talking about here. So there's the basic curve, y equals x squared. Now, this is probably more a thought process. You probably wouldn't draw each of the individual graphs that I'm about to draw here. You draw the final product. But I'm thinking, okay, I've got y equals x squared. Now I know I'm going to shift it to the right 3 units. Okay? Because I've got negative 3. It's grouped with the x. So that tells me it's a horizontal shift. What would make that grouping equal to 0? Positive 3. So I'm going to shift it horizontally over to positive 3. Okay? Now the next thing I see is the plus 4. Well, that's telling me I'm going to shift it up 4. If I was to group it with the y, I would have y minus 4. And again, I asked that question to myself, well, what would make that equal to 0? Positive 4 was. But when it's just added onto the function, it's fairly easy to tell anyway, because we're saying, hey, it's this curve, but we now added 4 to everything. So we're moving it up 4 units. Whoop, there we go. And so there is our curve, and the vertex is 3, 4. So when it's in that sort of completing the square type form, that's what I was saying the other day when we talked a little bit about quadratics, it's very easy just to read off the equation what is the vertex when we've completed the square. Okay, we can do it with any shape. This one here, I look at it and go, okay, I've got my basic cubic, because I see I've got y to the power of 1, x, albeit factorised with another number, is to the power of 3. So I know I've got my basic cubic. What have I done with it? Well, the negative in front of the x cubed tells me I've reflected it in the x-axis or flipped it upside down. So there we go. It's a negative x cubed we're dealing with here. Grouping with the x is plus 1. So I must have shifted it left because I've got to move it to negative 1. That's what would make that equal to 0. So shift it to the left. There we go. And then finally, I've shifted it up 2 units. And there's our new curve there. And so what was 0, 0 has been moved to minus 1, 2. Minus 1, 2. Ooh, x squared plus 2x plus y squared minus 4y minus 4. Looking at that, best I can say right now is that's a circle. Because I notice both the x and the y are squared. Coefficients are the same. Can't really tell where the centre is or the radius is. To do that, I'm going to need to complete the square. So, x plus 2x. Well, I know it's always going to factorise to be half the coefficient of x. So I know it's going to be x plus 1 all squared. With the y's, I've got y squared minus 4y. Half the coefficient of x is negative 2. Coefficient of y in this case is negative 2. So I know it'll be y minus 2 all squared. Now, this creates new numbers, of course, because if I was to expand this one out, I'd get a plus a 1. Expand the y minus 2 all squared out, I'd get plus 4. So I've added those to the other side, as well as moving the constant over, and we end up with 9. Now, a lot of you might look at that straight away, probably maybe even all of you, and you'd recognise it straight away and say, oh, the centre's at minus 1, 2, and the radius is 3. But here's how we think of it using the shifting idea. The basic curve would be x squared plus y squared equals 9. So that's our circle of radius 3. Grouped with the x, so we're shifting it to the left, because minus 1 would make that equal to 0. So I shift my circle to the left. Now, grouped with the y, and this time it actually is grouped with the y. So what would make that equal to 0? Well, positive 2. So we're going to shift it up 2. And sure enough, it's what you were expecting. There's the circle, centre, minus 1, 2. And radius, of course, is 3, although I didn't label it on there. Oh, that was very bad. Should have labelled the radius there. Okay, 2 to the power of minus x. Well, the basic curve would be y equals 2 to the power of x. This time, it's not the whole function I'm making negative, but just the x value. So that tells me I'll reflect in the y-axis, because it's the x we're making negative, not the whole function. And so we get our exponential going the other way. Okay, 2i. We shall try that.